Hi! In this video, we're going to solve the last exercise, exercise number 5. In this question, we have an electric motor, and we're going to do some changes and see what effect each of the changes below would have on the power of this electric motor. Let me remind you of the power. It is the amount of energy transferred or converted per unit time. And its unit is watt, which is equal to 1 joule per second. We should know that the power in an electric motor is equal to the voltage multiplied by the current. Now, if we reduce the number of turns of wire around the coil, what would happen? Does the power increase or decrease or stays the same? Note that when you increase the number of turns, you increase the voltage across. So I think you can give the correct answer now. That's true. If you reduce the number of turns, you reduce the voltage, and so the power decreases. Now, what about increasing the strength of the magnets on either sides of the coil? Of course, increasing the strength of the magnets means increasing the magnetic field, and that will increase the current. And so, what would be the answer? You're right again. This will increase the power. Now, if we increase the current flowing through the coil, how does this affect the power of the electric motor? Well, you seem thinking correctly. Increasing the current means increasing the power. Now, the last change we can make is changing the direction of the current. Would this affect the power of the electric motor? We do know that the direction of the current controls the direction of the rotation of the motor. So, would it affect the power? You must have answered correctly. It does not affect the power of an electric motor.